For this question, we're doing number 5 from the work energy conservation practice problems. Number 5 is the coyote, whose mass of 22.0 kilograms, is chasing the roadrunner when the coyote accidentally runs off the edge of the cliff and plummets down to the ground 32 meters below. What force does the ground exert on the coyote as he makes a coyote-shaped dent 0.450 meters deep in the ground? In this case, you almost have to take the reasoning in two parts. And the first part is, here we have the coyote runs and plummets a distance of 32.0 meters. At this point, you'll see that the coyote has a max potential energy. And right before he hits the ground, he has a maximum kinetic energy. All of the potential energy transfers into kinetic energy. And that, once he gets to hit the ground, it takes a certain distance to convert the maximum kinetic energy to a final kinetic energy of 0 joules, because that's where the coyote pretty much is stopped. So if that's the case, you need to know that whatever the coyote's maximum potential energy is eventually going to be all transformed to maximum kinetic energy. So because we are comparing these two locations, we know that this potential energy at the maximum point is equal to the kinetic energy at the maximum point. We also know that the work done in the case of changing the kinetic energy is equal to a force times distance. So one way I like to look at this idea of work is how it relates to force and distance, but it also relates to a change in kinetic energy, and also a change, if it changes kinetic energy, it'll probably change potential energy. So if you can find a change in kinetic energy, you can make it equal to a force and a distance. And that's what we'll do in this problem. So we'll add the fact that the mass of the coyote is 22.0 kilograms. The height that the coyote starts with is 32.0 meters. And the distance that the dent makes right here, distance, is equal to 0.450 meters. So if we're looking at this, we'll need to look at actually potential energy with our givens, mass and height. So we'll do change in potential energy equals mg times change in height, which is the same thing since he's falling to the ground of 32. So that equals 22.0 kilograms times, we'll use 10 meters per second squared, times 32 meters. Sorry, that's small. When you multiply all of this out, you should get 7,040 joules. So we know that if we have a change in potential energy, that's pretty much saying that we also have a change in kinetic energy. If we're looking, the question is looking for what is the force that the ground exerts on the coyote. You have to equate the change in potential energy with a force and a distance. We know the distance, and that's 0.450 is equal to 7,040 times force. So all we have to do is divide both sides by 0.450 divided by 0.450, and you get 7,040 divided by 0.450, 15,644 newtons. Or if you want to round, our rounding will probably be to 3 significant figures, so 15,600 newtons.